In this video, you are going to learn about angles in circles and angles on circles. And so here are some pictures of what I mean by angles in a circle and an angle on a circle. And we will explore the relationships between angles and arcs, and we'll also define some vocab in this video. So we'll learn what an arc is, a chord, a central angle, and an inscribed angle. So we're going to start by looking at some of these definitions. And so on the screen right now, you are looking at 3 examples of an arc. So these highlighted sections are arcs, and these are not arcs. So by looking at these examples and non-examples, what is an arc? So write a definition in your own words, and you don't need to Google the definition, but using just these pictures, what do you think an arc is? So one definition of an arc is it's the part of a circle lying between 2 points on the circle. So 2 points on the circle, it's that part of it lying between those 2 points. Or another definition is it's part of a circle's circumference. So the circumference is all the way around the circle. An arc is just part of that circumference. Another word that we'll need to know is central angle. So here are some examples of central angles. And here are some pictures that are not central angles. And so again, looking at these pictures, write a definition in your own words of what is a central angle. So one formal definition of a central angle is an angle whose vertex is in the center of the circle. So the vertex of the angle, or sort of the corner of the angle, is at the center. Another definition is an angle formed by 2 radii. So if you notice in all of these central angles, this is a radius and this is another radius. So a central angle is an angle formed by 2 radii. So now we're looking at another central angle, this angle here at B. And we can also see an arc between the letters C and A. So we say that this central angle intercepts arc AC. So we would say that angle B intercepts arc AC or CA. So this word intercepts here just means that this arc is sort of bounded by this angle. It's between those 2 endpoints on the circle. And on the screen, we can also see the measure of this angle, that it's 60 degrees. And just like we can measure angles in degrees, we can also measure arcs in degrees. And so this arc is also 60 degrees. And then when I move around points A and C, so if I click on one of these, I can change the size of the angle, which also changes the size of the arc. So what do you notice is the relationship between the measure of the central angle and the measure of its intercepted arc? So every central angle is equal to the measure of its intercepted arc. So no matter where we move points A and C, the measure of the angle is equal to the measure of its intercepted arc. We're now going to define another word, and that word is chord. So here are some examples of line segments that are chords. And these are not chords. And so looking at these examples and non-examples, write your own definition of a chord. A formal definition of a chord is a line segment whose endpoints are on the circumference of the circle. So notice in all of these examples of chords, the endpoints of these line segments are on the circumference of the circle. Now we are looking at another angle in a circle, but notice that this angle is not a central angle. It is not in the center of the circle. This type of angle is what's called an inscribed angle. And notice that AB, this line segment, is a chord, and so is line segment BC. These are both chords. So an inscribed angle is an angle formed by 2 chords who share an endpoint. And so this angle that we're looking at here is 18 degrees, but if I move around any of these points, we can see that the size of the angle is changing. But all of these angles that we're looking at here are examples of inscribed angles. So we're going to figure out the relationship between the measure of this angle and the measure of its intercepted arc. And so here, we again have an inscribed angle over here at angle B, but now we're also seeing a central angle that intercepts the same arc. So notice that both of these angles are sort of bounding in this same arc. So what we learned a moment ago is that the measure of this arc is equal to the measure of the central angle. So arc AC would be 80 degrees because it's the same as the measure of the central angle. So notice that angle B is not the same as the measure of its intercepted arc. So instead of the inscribed angle being equal to the measure of its arc, how are these related? And we can look at some more examples here. So I'm going to clear that 80 off the screen. And if I move around any of these points, again, we can change the measure of the angle, but we're still looking at all inscribed angles. So again, maybe you're noticing a relationship between the measure of this central angle, which is equal to the measure of this arc. So what we're looking at right now, the measure of arc AC would be 50 degrees because it is equal to the measure of the central angle. So after looking at another example, what is the relationship between the measure of the inscribed angle and the measure of its intercepted arc? So hopefully you have noticed that the measure of the inscribed angle is half of the measure of its intercepted arc. Or another way of thinking of that is that the arc is double the measure of the angle. And so even if we look at some smaller inscribed angles, so if we move A and C closer together, that the measure of that inscribed angle is still half the measure of its intercepted arc, or half the measure of the central angle. And even as that angle gets bigger, so let's say we make the inscribed angle all the way up to 72 degrees, then notice that it is still half of the measure of this intercepted arc. So in summary, we have learned that a central angle is an angle whose vertex is in the center of the circle, and the measure of the central angle is equal to the measure of the intercepted arc. The measure of the angle and the measure of the arc are equal. An inscribed angle is an angle formed by two chords that share an endpoint. And the vertex of this angle is on the circle. It's on the circumference. And an inscribed angle is half of the measure of the intercepted arc. So if the arc is 70 degrees, then the angle is half of that. This angle would be 35 degrees. So again, in this video, we have learned about angles in circles and angles on circles. Next class, we will learn about angles that are outside of circles, like the one in this picture.